This is the most advanced calculator ever created in Rust. Punch in any calculation of your choosing and it will display it in seconds. All 4 arithmetic operations are included and you can even calculate 5-digit numbers. How is that possible? Well, it works with these electrical components. A lot of them. Also, his name is Edison, he's a good calculator and I will defend him till my death. So let me show you the inner workings of this splendid machine, give you some questionable calculus tasks, and maybe you will learn something about computers along the way. Alright, remember math class? The one where the book has more problems than a solo getting to tier 3? Ah yes. Nip the Naked has 1008 pumpkins. He finds 4 more. How many pumpkins does he have? Easy, it's 1012. But notice the numbers we are using. We humans have numbers from 0 to 9, 10 different numbers in total. Therefore we call it base 10 or decimal. We can count up to 9, the highest number in our system. If we want to go higher, we need to put a new number in front and null the other, until this number as well reaches 9 and the process repeats. Doing maths in Rust, we run into a problem. A wire can only be off or on, 0 or 1. Only 2 different numbers, meaning we have a base 2 system, or binary, just like a computer. Ever wondered how a computer does calculations? Come here, I'll show you. We count up as we did before. We have 0, then 1. But 1 is our highest number, so we cannot put 2 next. Instead we do the same thing as we did with 9. We increase the next digit instead and null the current, meaning this is 2. Following the same logic we can count on and on. Notice how a single 1 always represents a power of 2. Using this we can easily read a binary number, write the power of 2's on top and add them wherever we find a 1. So this binary number would be 23 in decimal. Alright, let's tackle the first operation, which will be a big plus. The simplest operation is addition. Gib the Grub has 69 boogie boards and crafted 42 more. How many boogie boards does Gib have? When adding in the written form, we do them digit by digit. First we add the 1s, then the 10s and so on. If we add together 2 digits that sum up to more than 10, we carry one over into the next pair of numbers. In binary we do something very similar. We add each pair individually, which is super easy as there are only 3 outcomes. When both digits are 0, the result is 0. It is 1 when either of the 2 are 1, and when both are 1, it's 0 again, with a carry to the next digit. We can create a circuit doing the same. If we play around, we see it mimics the desired behavior. Wow, we just created our very own half adder. Why half, you ask? Well, there's one thing we haven't accounted for. What if the previous digit already has a carry to the current digit? We can take this one in consideration as well, and suddenly we have a full adder. Put multiple of those in a row, and we finally can add numbers together. 1 and 2 is 3. And add 2 and 2 together and we see that it carries over to give us 4. For larger numbers we can just increase the number of full adders. And for our boogie board example, we see when we add 69 and 42, we get the expected 111. Now that's a great addition to our calculator. Splendid! One issue though is our presentation. It is tedious to look at each bit and calculate the number in our head. An easily readable format would be great. Therefore we need a way to convert binary into decimal. Luckily the counter can help us. Instead of using its count function, we use the pass-through function, meaning it will display the power applied to it. Using root combiners allows us to add the power of 2 wires together. Just do that wherever a binary number is 1. In this example we have 10 in binary, for which we add 8 and 2 together. for a total of 10 power that goes to our counter. Now this looks way smoother. Do you like the video? Then subscribe, because just like the calculator, you can always count on me. Minus. For subtraction, we can just add two numbers together. What? You see, there's a neat trick with binary numbers. We only need to invert the second number, meaning turning every 0 into a 1 and vice versa. And if we now add 1, the resulting number will be the one we are looking for. If this sounds like some binary black magic, that's okay. In the video description there's a more detailed explanation for those interested. After this, we want to do the same as a college freshman. Multiply. Okay, say Zip the Zerker and his 19 friends each have 123 AKs. I know that's unrealistic. Rust players don't have any friends, but we want to multiply 123 by 20. Doing them by hand, we go through each digit, multiplying with the other number and sum it all up. So 20 times 1, times 2 and 3, altogether 2460. Multiplication in binary is even easier. The second number either gets multiplied by 1 or 0. As multiplication with 1 is just the number itself, we just write it wherever the first number has a 1. Finally, add all together and we have our result. For a circuit, we can do the same. Just add the second number wherever the first one has a 1. We can think of this as many conditional additions. Good thing we already have a circuit for addition. Make it conditional and chain it multiple times, and we have a multiplication circuit. And again, it gives the correct result for our example. Next, we mimic Face Punch with the recoil update and create some division. Division is the hardest of the 4 operation and takes longer than respawning mid-rate. Looking at it once more from a written form, we go through the first number and see how often the second number fits in that place. If it does fit, we write down how often it did and subtract that number. This seems similar to multiplication, doesn't it? Instead of conditional addition, we now have some conditional subtraction. Great that we already have this circuit as well. We just need to create a circuit that checks whether one number fits into the other. Chain them together once more and we got division. Pip the pilot has 150 fuel and his scrap heli takes 30 per minute. Now we can calculate that he will be airborne for 5 minutes. We have all the different arithmetic operations, but we still need to tie them together into one functioning calculator. How does the input get processed and how does the calculator know which operation to use? In this calculator we have 3 different variables, a, b and c, where a and b are our operatives and c is the result. To store them we use the register, just like a computer. In here each number's binary value is stored in 16 bits and we can read and write from them. Inputting is done 1 digit at a time. The first one is quite easy, we just save it in A. For the second digit it's a bit harder as A isn't empty anymore and we need to move the existing number 1 digit over, meaning multiplying it by 10. Afterwards we just add the new input on top and save the sum in A again. Once an operation is chosen, we can do the same for the second number in B. The calculator will remember what operation we've chosen, and when we press equals, it will write A and B to the right circuit to do the arithmetics. Once the circuit came up with a result, it saves it in C and we finally have our answer. And for all the nerds, here are all the sizes of numbers we are able to calculate with each operation. Great, we have it all up and running. Now a normal person would consider this a job well done, but you see, I'm not a normal person. In the current state I'm deeply unsatisfied with the size of my calculator. It is missing a certain impact to it. Let's make it bigger. 2 times, no, 5 times, 10 times bigger. Choose the right building skin. Add custom signs. Make a display with over 2000 lights and...
1 eternity later.
It is done. It's perfect. Don't ask me how long this display took. As a matter of fact, we can't just put the number on there, but we need to convert it first into binary counted decimal. And all of these components are just there to do that. And if you're curious, yes, it of course can display the most important number of any calculator. Let's put it to the test. Our very first example was 1008 plus 4. So we type in 1008, which will be saved in A, and select 4 for the second number in B. Hit equals, and our result C now gets converted and displayed in the last step. We can now do this for every single operation. Minus, multiply, and division. It still feels like it's missing some personality. Let's give it a face. More personality. Splendid. What would be a good name? A calculator does addition, Addison. He even thinks for himself and tells you when he's done. Let's finalize it by adding a sound to each button on the calculator, making it even more interactive. A note from Addison? Add 24 and 46 together? Well, sure. Wait, no! And people say you don't learn anything playing Rust. Hopefully you did watching this video. And if you think this was a lot, well... let me tell you, it's only the beginning. Subscribe to not miss out. I see you in the next video. Splendid.